What's up, guys? Welcome to my channel and welcome to my very first video. I am super excited to get this started. I've been wanting to make a YouTube video for a very long time and I'm very glad that I am actually starting. So for my very first video, I thought that we can dive into HackerRank and I can show you guys and walk you guys through one of the problems, right? So the one we're going to do today is diagonal difference, and we're going to tackle this in Python, right? So what I want to do is for this video, just walk you guys through my thought process when I'm figuring out these HackerRank problems, and hopefully this help you guys, or if you guys can give me pointers, because I'm more of the very beginner intermediate side of Python. So all of these solutions might not be the best solution, but for my level, this is all I know, and I feel like this is the best way to do it. So I am always open to critique and ways to improve myself. Without further ado, let's get started. So the first thing I want to do is just take a read through my problem and figure out exactly what I need to do, right? So given the square matrix, kind of like the absolute difference between the sums of its diagonals. For example, the square matrix of array is shown below. 1, 2, 3, array of 1, 2, 3, array of 4, 5, 6, array of 9, 8, 9. The left to right diagonal, 1, 5, 9, which is left to right diagonal, equal to 15. The right to left diagonal, 3, 5, 9, which is equal to 17. The absolute difference is 15 minus 7. Absolute value of that is 2. Complete the diagonal difference function, which is right here, and below. Diagonal difference takes the following parameter: integer, array of position n and position m, an array of integers. Return an integer, the absolute diagonal difference, which we saw here. Input format: the first line contains a single integer n, the number of rows and columns in a square matrix array. Each of the next n lines describe a row, array of position I, and consists of n space separated integers at array position I, position j. So the constraints: we have negative 100 is less than or equal to array of position I and position j, and that is less than or equal to 100. Output format: return an absolute difference between the sums of the matrices two diagonal as a single integer, as we saw up here, and as we also see down here in our sample input. 11, 2, 4, 4, 5, 6, 10, 8, negative 12. So from left to right, we have 11, 5, negative 12. And then from right to left, we have 4, 5, and 10, and that should output 15. And also it explains what a primary diagonal is and a secondary diagonal is. Right? So let's get started. So the reason I have Python open is because I really like doing my problems in Python versus the HackerRank IDE, because it's kind of difficult for me to debug in here. So I really like using the Python tools. So first thing I want to do is just copy over the function that I need to use. Right, so let's go back to our problems and write a little bit of comments about what I need to help me along the way. I'm going to comment, so my input is going to look a little like this. It's going to be an array to be filled with other arrays. And these arrays are going to have some values in it. 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So my output should just be an integer, right? Something like 15. Let's put 15. That won't be the answer for this, but that's just the type of thing I need to get an output on, right? Or a type of output I need to get, or what my output needs to look like. So going through this HackerRank problem, there's not really much else that I need to write down. It's pretty much a really simple problem. Let me look through here a little bit. Yes, but when you're doing this, if there's more information that might help you solve your problem, feel free to add more comments, but this is enough for me. First thing I want to do, so I know that I need to add some values in here, right? So best way for me to visualize this is just get these on a separate line and line it up correctly, right? So I know I need to add this position, and this position. I also need to add up this position, and this position. So the most basic approach that I can think of, I like to start with the most basic approach and then just build off that into a more complicated approach, right? Because most of the time, or I won't say most of the time, a lot of the times, complicated solutions are not the answer. Usually simple solutions are generally the answer, You don't want to spend too much time on a problem than you need to, right? So I like to start with a simple solution to see if that is the best case, if that will actually work. And if not, go into something more complicated. Unless I know off the beginning that it's going to be complicated, right? That's just my thought process. So the naive approach or the most basic approach would be, I don't need to add this, this, and this. So I can just easily just index these numbers and then put them into add them together and put them into a number, right? I could add 1, I can add 5, and I can add 9 and put that into a number. I can also add 3, 5, and 7 and put that into a number. Subtract those and then get the absolute value and then print it out, right? So this is not wrong. It would work. It would work for our sample case down here. If we added 11, 5, negative 12, and 4, 5, and 10, added that together, get the absolute difference, it will be 15. So that would work. However, this would not work if we had more numbers in the array here and we had another array going down. Or let's say we had 15 arrays or we had 20 arrays. This would not work because we would only be calling or only be indexing these first 3 numbers. Right, so that would not work. So what we will need to do, usually when there's an array, you gotta get, or usually when there's an n amount of arrays, you will need to loop the array and get some values. So exactly what we're gonna do. We're gonna use a for loop for I in range of the length of the array. Right? So every time you get a new array, it will have you can use the length value to figure out how many arrays are inside of this outer array, right? So if there's 3 here, the length is going to be 3. If there's 4 here, the length is going to be 4. And no matter wherever the length is, that's going to be the same amount of digits inside this array or values inside this array. So if there's 4, if the length of this array or this array is 4, there's going to be 4 numbers in here. If it's 5, there's going to be 5 numbers in here, right? So we can essentially get every single number in here with this I. All right, so let's just start with our sample input here. So we know there's 3. We know there's 3 numbers and there's going to be 3 arrays. Right, so for I in the range of length of the array, let's just go ahead and print what I is. And then come down here, let's call our function diagonal difference. And let's pass in, let's go ahead and just pass in our sample input, right? Let's do it here. 11 to 4. Let's go ahead and do 4, 5, 6. And let's go ahead and do 10, 8, and negative 12. Let's just see what this gives us. From this. To go positional argument. Oops, I forgot to add my outer array to here. Nope, whoops, that's what I forgot. The parentheses. Oh my goodness. Okay. So, right, so length of the array would be 3, and this 4n, or excuse me. So, yeah, the length of this array will be 3. This right here is giving us 3. For I, the range function doesn't include the last number. So this is essentially just saying in range of 0 to the length of the array, which is 3. So 0 all the way up, but not including 3. But shorthand, you can just put one number and it will go from 0 all the way up to that number. All the way up, but not including the number. So it's just, as you can see here, I gives us 0, gives us 1, and it gives us 2. So coming into here, we know that we need a number. We need 2 numbers that will subtract from each other and get the absolute value, right? Right, so what would our number 1 consist of? It will consist of this array, so this outer array at position 0, which will be here, and we get the first number, which is at position 0 again, right? So let's go get array at position 0, excuse me, at position 0 again. But as we said, we can't just call it directly because we have no idea how many numbers we will have in here. So what's the better way to do that? We can use this I right here. The first iteration of this for loop will be 0, right? So we can just put I here because it's going to be 0 here. It's also going to be 0 here. So we get this. But as we loop through this, it will keep being, and this actually helps us solve our problem, right? So, and as we loop through it again, this will be 1, as we can see down here, it's going to be 1, 1, which is here, the first index of this, and then the first index of this. And we're adding that together. Third time it goes through, it will be 2 here. So I will be 2 here, I will be 2 here. This will be second index, and this will be the second index. So that number 1 is solved, right? Or, excuse me, we didn't add it together, we're just assigning it to that, so that's not helping us. We need to keep adding it together, and of course we need to set this to 0 up here, set this to a value up here, because every time we go through this array, we need to update something. We need to update this 0. If we put it inside our for loop, it will continue every single time it goes through, it will set it to 0, and we don't want that. So num2 is do the same thing for that. And here, we want to add in our array at what position though? So we need to get this first array. So there's going to be this array at position 0, or index of 0, which would be this array, right? So let's put a 0 here. And then we need to get this index, which would be index of 0, 1, 2. This would be 2. So as we said previously, we know our first number in I will be 0. So we get in all will be 0, and then it'll be 1, and then it'll be 2. So we're getting 0 on the first round, we're getting 1 on the second round, and we're getting 2, the index of 2 on the third round, right? So we put that there, and that will solve our problem there. But in here, we can't just put 2 because it will be 2 every single time, and that will not give us the right answer. So what can we do here, right? So we know we need to get on the first iteration, we know we need to get the very last value. So how can we do that? Same thing as we said up here, length of the array. Length of the array, right? But length of the array. So what is this exactly return this? What does this gives us? What number will this put in here? So as I said up here, this length will give us how many digits are inside of this array, right? Or how many values are inside this large array, which is technically 4. So, or 3, 1, 2, 3. So this will give us 3. So essentially this is giving us on the first iteration, this will give array at position 0, which is here, and then at position 3, which we don't have. So that's incorrect. So what we can do is subtract 1. This will give us 0 in position 2. Position 2, right? And so this is the index of 2, so we are good. On the next iteration, when I is 2, we'll get, or excuse me, when I is 1, we'll get array at position I, which will be 1, which is here. But then here we get length array, which is still 3 minus 1, which is 2. So we'll get this number again. So how can we fix that? So here, so we know our I, first iteration it'll be 0, right? So let's see, the first iteration it'll be 0, and the second iteration it'll be 1. So length of array minus 1 will be 2 each time, right? And then you want to minus this I, which starts at 0. Minus this I, which starts at 0. And then so length of array minus 1 minus first iteration 0 will equal 3 minus 1, which is 2, minus 0, which will still be 2. So you get this one. Next iteration, I will be 1. So 3 minus 1, which is 2, minus another 1, which would be 1, which would be this one. And then again, next iteration, I will be 2. So 2 minus 1, which is, 3 minus 1, which is 2, minus 2, which would be 0, which would be here. So that should solve our problem. Let's see what we get here. Excuse me, I did not. Here. Oh, I didn't return our numbers. Let's go ahead and return num1 minus num2. Let's see what that gives us. just going to print the return of this. So it gives us -15, and we know that we need to get the absolute difference of it. So we can use the Python function absolute, the built-in function, and see what we get. We get 15, which is exactly what we need. And we can just come in here, copy this, paste this into here. Let's go ahead and put there. Let's fix our indentations. And yeah, so let's run our code. And we got our sample case 0. We figured that out. Let's see if we can. When we submit our code, let's see if we pass all the other sample cases. And we do. So that's how you solve diagonal difference. Like I said before, this is my first video, so if I was a little bit choppy, I will try to get better at that as more videos go on. But for now, please give us a thumbs up, share it with your friends if you think this will be beneficial to them. Please give me some recommendations in the comments on how I can improve my coding skills, as well as any other videos you guys would like to see on my channel. And so for that, we are done, and thank you for watching.